Hi. In that previous course overview lecture, we have discussed about what we are studying in the Mathematical Physics 1, and we find that three essential questions to understand any physical phenomena through in that course, and these three questions were: what is happening, where is happening, and in which rate it is happening. We can get the answer of what from the linear algebra, and the where it is happening, and that's from the vectors and the coordinate systems. So it is our the first, this is our technically the first lecture where we are discussing the vectors and the dot product in that lecture particularly. So before we, let's first start with that physical quantity. What is physical quantity? If anything, the scientific experiment you are going on, you need to measure something. What you can measure? You can measure a physical quantity. Now two types of physical quantity you will face. One is, of course, what does not require any direction. The some like if you going to a butcher shops and ask for a meat, okay, he can gives you meat with a 500 grams meat. This 500 grams is enough to describe what you want. So this is there no any necessary data need to describe it. But for a case that you are standing on the road and someone come toward you, and he's asking for a nearby hospital, then what you will give the answer? Then you can do, what you can do is you can tell him that 200 meters in the north. Here only 200 meters is not enough to describe your scenario. Here with the 200 meters, they need to on another additional information, that north, the direction, that can gives the entire that can gives you the entire idea of the scenario what you actually want to know. Okay. uh, Another additional information is, if you want to have the study material or our study material, you can visit in our website. There you can find our study material. Okay, so here we get two type of physical quantity. One is what does not need any direction. We called it scalar. Only magnitude is enough for an scalar. Okay, and another type of physical quantity is vector. What we are going to study today, or in that segment of that module, in that module we are discussing mainly about the vectors. So these vectors, it does have the magnitude. Of course it does have the magnitude, plus it have the direction as well. So what is the vector? Vector has magnitude and direction as well. Now we are going to have some vectors rule, some basic rules that a vector can transfer or shift in a space from one place to another place without changing its direction. This arrow of the vector tells about the direction, and the length of the tail about the magnitude. So the larger the length of the tail, the magnitude is high of the vector is higher, and the lesser the tail is, magnitude of the vector is less, and this arrow is tell us about the direction. But with that, we need to understand the scalar multiplication as well. What is scalar multiplication? Something that k is something scalar, it does not have any direction. If you multiply it with a vector, so it will change in its magnitude. You can see that from that a and this after the multiplication, the tail is enlarged. That means that you have a greater vector, and it also does means that the value of k is greater than 0, that means in the positive, so the direction is not changed, the same. Also you can see that as the tail is enlarged, the vector is enlarged, so it necessarily k is also not only greater than 0, k should be also greater than 1, and this is the minus a. That does mean if a vector is there, if you want to find its negative vector, it's of course was exact opposite. You can do this task yourself. Find the vector subtraction. When you know the vector addition, one thing you only have to remember: the vector addition subtraction is the plus of the one of the negative vector. You can now find the negative vector. How you can find the negative vector? Negative vector is the same magnitude but only the exact opposite direction. That is the negative vector. And from, if you know to understand the negative vector, you can easily find the vector subtraction as well. Okay, now vector addition. Two types of vector addition we will understand, but we'll find that the result we are getting from the two types are the same. The first one is the triangle law. The first one is the triangle law. What is triangle law? If you place two vectors side by side to form a triangle, and its first tail to last head, actually this is the tail and this is the head, and so for this you can get a result, and the third one of the triangle, third side of the triangle will be resultant, and the direction of the third side is opposite of the first two. Like this is A is going toward this, B is going toward this. So technically in the same way, if it was going, it should be in that direction, but it is not. If you find the resultant would be in that direction. So it is the head of A and tail of B is connected, and then we get the C, the resultant one, and that is the opposite direction. Now in another way we can find the vector addition, that is called parallelogram law. Okay, here we add the vector tail to tail. Two vector A, and the tail of A and the tail of B are added, and we are finding the vector resultant. What is the resultant? The diagonals are resultant, and the direction is all as the A is inside this side, A along A, B along B this side, and the direction is that side. Okay, now you can see in the both of the two method of vector addition, you are getting the same result of the C. If you know the from the first slide, you can see that we can change the vectors, we can shift the vectors. If you shift the B from here to there, you will see exactly the triangle law become the parallelogram law. So the parallelogram law and triangle law gives us the same resultant, but in some another way. Commutative law, if you find A plus B and if you change the position of A and B, you will get the same resultant C. Okay, so it follow commutative law. And if you have another vector, if A, B and C, so if you add A plus B, you get a vector, and you add with the, you find a resultant with adding with the C, you get another vector, that A plus B plus C. Well, A plus B plus C. So this vector also follows the associative properties. Now now let's understand about the vector component. Something, a vector is there A, it can be written as with their component. How? Like this is our vector A. Now we have to find in the value of each component. In x direction, it is something, the component is ax, and we can write with the ex. Well, we'll discuss about this term ex, that too, but first we are writing down the entire vector. Okay, a y u y along plus a z Ez. Okay, this Ex is actually our unit vector. It is also an important concept, unit vector. What is unit vector? Unit vector have a direction, but magnitude is 1 always. So it is Ex, that does mean unit vector along with x-axis. Ey does know what that mean? That unit vector along with the y-axis. Ez means unit vector along the z-axis. Now unit vector can be written in many ways. In some places you can see in the notation like that ex cap, and more standard in the, you can also see some in some places that is the I cap. sorry, I cap, j cap and k cap. Okay, it is not important to use any particular notation. You can use whatever you want, but it is two more standard terms of to note a annote unit vector. Now, magnitude of a vector, you can find a magnitude of a vector. If it is a vector, you can write with this component ax, y, ay and az. But you can find also the magnitude. What will be the magnitude? Magnitude is the root of all the component ay square plus az square. That is the magnitude of a vector. Okay, now one another interesting addition rule is component addition rule. Something, if you get if you multiply a scalar k with a and a k prime with the another vector b, what the resultant you get is, if c is equal to that, then for every component this is true. Like for cx, you can find that ax into k plus k prime b x. Okay, for y it is samely true, and for the z it is also true. So the next slide, the direction cosines. The direction cosine is a thing that we can find the component. What is the component? Suppose the vector a and the angle between vector a and the x axis is alpha. Vector a with the y axis is beta, and vector z with the z axis is gamma. Okay, then we can write that ax is equal to a cos alpha, a y is equal to a cos beta, and a cos gamma. Now another thing, fundamental identity, that you can prove this too. How you can prove? Yeah, okay, let's see. You have seen that a square, or magnitude of a, is equal to ax square plus a y square plus a z square, right? Now what you can see, that ax square is equal to a square cos square alpha plus a square cos square beta plus a square cos square gamma. Okay, now if you take a square common here, then you'll see only that a square cos square alpha plus cos square beta plus cos square gamma. Okay, and for that a square there will be cut off, that so that these terms will be 1, as you see that fundamental one of the fundamental identity. Now another important concept is the projection. So the we are entering the dot product here, and the dot product is important because it will help you to find a projection of sum. Like if you see that ax ex c cap, it is a unit vector, it does mean it is a projection of vector a along into the x direction. Okay, now you can write that ax is equal to component is ax and a cos alpha. You have seen it in the previous slide. Now distributive law, if you find if you know that how to write a vector, like a is equal to vector a is equal to ax ex plus ay uy plus az ez. Same way you can write the vector about the vector b and vector c, and then you can find that whether it is true or false. Okay, this law is called distributive law, but you can verify yourself from using that ax is equal to b and b the vector v is equal to bx c cap plus by. and the same way see, and you can find that whether whether this vector follows the distributive law or not. Now orthogonality, and another important question, important aspect of this vector is the vector orthogonality. How you can find a vector orthogonal or not? By simply using the dot product. How? We can see the definition. We can define the vector dot product A dot B as mod of A mod of that is magnitude only, okay, and there cos theta. Theta is something the direction between A and B. Okay. Now when it is orthogonal, it is then orthogonal then when this theta value is equal to pi by 2. That can be plus minus pi by 2. When it is plus minus pi by 2, then that means this is a perpendicular, okay. And now what is the value of cos pi by 2? 0. Yes, the value of cos pi by 2 is equal to 0. So when it is orthogonal, that does means that that entire this result is will be 0. So when it is orthogonal, when A dot B is 0. And now you also we can do, we have to understand the dot product of the unit vectors along with the different Cartesian coordinate, okay, along with the x axis, y axis and z axis. Now how we can find? If you think that ex for the same direction, that theta, what the theta will be, that theta will be 0, so it will gives you the answer of 1. And for the different perpendicular direction, not different direction, perpendicular direction, something that one is along the x axis and another is along the y axis, you can find it is 0, because the value of theta pi by 2, the value of cos pi by 2 will be 0. So you can find, if you have to check if any two vectors are orthogonal or not, what you can do, you can simply put find their dot product. If it is 0, then it is orthogonal. If it is not, then not. Now we can find the dot product of two vectors, like vector A and vector B. We have you can check it at yourself, like using that expression, vector A and vector B. What we can get it, every time we are multiply Ex with the Ex, it will gives you 1, okay, and Ex with Eu, it will give you 0. These are not equal, it will be plus, and what will be there? So ax, bx, ex, that will be ax bx, because ex dot ex will be 1, as we have seen in the previous slide, and ex with ez or ui will be 0. So only three terms will be there: ax bx, ay by, and az bz. So finally we can write that ax in that form, or we can or more fancy form in the summation form, 1 I1 B1, okay. And now we have two type of we have seen the two both of the form of the dot product. One is A dot B, that means A mod of A mod of B cos theta. It is more of a geometric definition, because there is an angle and that's all. And another is the algebraic definition. What I have in the previous slide, you have seen that finding A dot B is equal to ax bx, ay by, az bz. So but these two different type of forms give you the same result, and that is that is our dot product. Now another thing, some advanced cosine law theorem, okay. Now we can have C by the triangle law, A B is C. Now we can find the square of C as well, okay. What will be the square of C? That is A plus B dot A plus B, okay. So that means A square plus B square plus 2 A dot B. Okay, now this is to A dot AB. Now you can find the relation of A dot B. Another relation of A dot B, it is a advanced theorem, law of cosine. We are saying that this is 1 by 2 C square. You can minus it from A square and B square minus B square, and you can get this as exactly it is. Okay, and the final concept for today's lecture is Schwarz inequality. If there is A dot B and mod of A dot B will be always this will be less or the 0. Why? Because in that term there is not cos theta, but here is that A dot B is equal to A B cos theta. We can say mod of A mod of B cos theta. Now the value of cos theta cannot be more than 1, so so that A dot B will always either less than or equal to that mod of A and mod of B. Okay, thank you so much for the lecture. If you want to have some study material or practices some quizzes, you can visit our website. There is enough amount of study materials and practice set. You can practice as much as you like. Thank you so much for this. Next, see you in the next lecture.
वीडियोस बनाने हैं, फिल्मोरा है ना।